Hi, and welcome to the section of the Advanced Calculus 2 tutor. And in this section we're going to study a certain kind of series called the alternating series. And we're going to try to figure out a way to test to see if the alternating series converges or not. And I think of all of the tests that you'll do in series convergence, this is probably one of the easier ones, so we'll just jump right on into it. Note that an alternating series, okay, is a series that just has the signs flip-flop from positive to negative, and we've kind of talked about some of those series before. So it might be positive 1/2, negative 3/4, positive 5/8, negative whatever. So it's positive, negative, positive, negative. Every term goes back and forth and back and forth, okay? So just to kind of lay that on paper, the alternating series is where the terms go alternate sign. So positive, negative, and so on. So an example would be like 1, 1/2, plus 1/3, minus 1/4, plus 1/5, minus ... So it's a series, so I'm adding them up, but it's just that each term is negative, negative, positive, okay? So that's basically what that means, okay? And if you were to write this down, that would look like something like n is equal to 1 to infinity of negative 1 to the n minus 1 over n, right? So what you have here is this negative n to the n minus 1 is a cheap way to get the thing to alternate, right? So at n is equal to 1, you have negative 1 to the 0 power, which is 1. That drives the first term positive. When n is equal to 2, 2 minus 1 is 1. Negative 1 to the first is negative, so that makes it negative. So this negative 1 raised to the power of something just makes the sign alternate, and then the n on the bottom is just the number. Okay, so this is the general form of an alternating series. It alternates signs. That's all it means. Alternating series just means the sign alternates, okay? So recall that in general, if I have a series, n is equal to 1 up to infinity of the terms a sub n, right, I'm adding them all up, if we find that the limit of the elements of the sequence that we're adding up, n goes to infinity of a sub n. There's no summation here. I'm just looking at what the terms do. If I find that this goes to 0, then what have I found? Then the series may or may not converge. Okay, all it's saying is that in order for this series to have a hope and a prayer of converging, the elements, the things that you're adding together must approach 0. That's just a universal truth. If they don't approach 0, you're not going to make any headway. There's no way you can add something up that doesn't approach 0 and get anything other than infinity. And what we're going to find is that the alternating series is kind of a special case of this whole thing. So what we're going to do is we're going to write down the alternating series test right here. And this is what we're going to apply in this section. The alternating series test. Okay, this is really the bread and butter of the section. It's really not that hard. If the alternating series which can be written as something that would look like n is equal to 1 up to infinity of negative 1 to the n minus 1, which just makes the signs alternate, of the terms a sub n. So here's the part that makes it alternate, and here are the actual, the elements that you're adding together, which would be written as something like a sub 1 minus a sub 2 plus a sub 3 minus a sub 4 plus ... Okay, so you go on and on to infinity. You're just adding, subtracting, adding, subtracting. That's all an alternating series is. So if the alternating series, which can be written like this, satisfies the following two conditions, what we're going to say is if the series satisfies the following two conditions, then it will show that it does converge. And the two conditions are as follows. First condition is a sub n plus 1 is less than or equal to a sub n. And by the way, I write things like this on the board not because I think it's clear. I write it that way because in the books you're going to see things like this and you're going to have to look at it and say, oh, I know what that means. Well, that isn't very obvious to a lot of people. All this means, and I'm going to put it down here, for all n, all this means is that the terms in the series decrease. Okay? You're probably not going to see in a calculus book a theorem written in terms of the terms in the series decrease. I mean, usually they're going to write it in some mathematical notation like this. But look at it. What you're saying is a sub n plus 1 is less than a sub n. So what you're saying is the next term is greater than the previous term, is less than the previous term, is what you're saying. The term that comes next, that's what the n plus 1 is less than the one that came right before it. So the terms decrease, they go down, 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 which is kind of like what we said over there. The terms must go down in order for you to have a hope and a prayer. And B, very specifically, the limit is n goes to infinity of the terms that you're adding together must be equal to 0. So if both of these conditions are true, then the series, which is an alternating series, converges. Okay, so on your test or on your quiz or whatever, if you're given an alternating series, which is a dead giveaway, -1 to the something is usually going to be an alternating series with alternating signs. You're pretty much going to have to do this. And what you need to do is you need to look, do the terms decrease? If yes, check. Does the limit actually approach 0 of the elements of that sequence that you're adding up that becomes that series? If both of those things are true, then that series converges. If they're not true, then that series is going to diverge. Okay, so the first problem is a series that's something like this. 3/5 minus 3/6 plus 3/7 minus 3/8 plus 3/9 minus ... So that is a series. Okay, I'm adding those things up. It just so happens that some of these terms are negative, every other term. Okay, I want to find out if that thing converges. Certainly is not obvious at first glance if that alternating series converges, because look, you're adding something, then you're subtracting, then you're adding, then you're subtracting. It's really hard to look at these things and really understand if they converge right away or not, because then you add, and then you subtract, then you add, and then you subtract. So it's really, you're adding and you're taking away, and so does it converge or not to a number? And so you have to use this alternating series test to find that out. Okay, now how would we write this series? I think you can convince yourself that you would write this series as n is equal to 1 up to infinity of -1 to the n minus 1 times 3 over n plus 4. This part just makes it alternate as we talked about before. N is equal to 1, you'll get a 0 exponent, which is going to give you positive. N is equal to 2, you're going to get 2 minus 1 is 1. -1 to the first gives you this negative. And here, 3 is always in the top, and on the bottom, you have n plus 4. So 1 plus 4 is 5, 2 plus 4 is 6, and so on. So that's how you would write the series. The question is, does it converge or not? So let's check. Let's check and see if it converges, okay? Part A, do the terms decrease? Do the terms decrease? I think you can convince yourself. And when I say, by the way, the terms, I'm not talking about the sign of the terms. I'm just talking about this part. Everything other than the alternating part of it, does it decrease? I think you can convince yourself pretty easily that they do go down, because as n increases, this denominator gets bigger, and this is going to go down, down, down. So yes, okay? And for B, you just want to check, just for formality on your test, as n goes to infinity of 3 to the n plus 4, okay? Put infinity in here, you're going to get infinity on the bottom, you're going to get 0, so the limit does approach 0, so both conditions are satisfied. Terms decrease, limits does approach 0, so the series converges. The series converges, okay? The next problem would go like -1/2 plus 2/3 minus 3/4 plus 4/5 minus 5/6 plus ... Okay? So that's an alternating series, negative, positive, and then of course you have your terms. So how would you write that in terms of a summation? N is equal to 1 to infinity. You're going to have the part that does the alternating, which is that, -1 to the n plus 1. Now what would go here? Well, notice that for every one here, the top is 1 less than the bottom. So what I'm going to have is n over n plus 1. So for n is equal to 1, I have 1, n is equal to 1 here, I have 2 on the bottom, and so on. If you plug in different n's, I think you'll see that that fits, okay? So what we have to do is check, okay? Do the terms decrease? Do the terms decrease? Okay? Well, let's look at them. We have the terms right here. And by the way, again, just to reiterate, I don't mean the sign of the terms. I just mean the absolute value. Well, I've got 1/2, 2/3, 3/4, 4/5, 5/6. It sure does look like they're increasing to me. So the answer is no. The terms do not decrease. And because of that, it's sufficient to say right then and there, this series diverges. Okay? And you could also take the limit if you want to. Limit of n over n plus 1 as n goes to infinity. You'd be in L'Hopital's rule territory because you'd have infinity over infinity. So the derivative of the top will be 1. Derivative of the bottom will be 1. So you'd have 1 over 1, which is 1. So that limit of this guy goes to 1. It does not go to 0. So that means the terms that you're adding together do not approach 0. There's no way that adding up an infinite number of those things is ever going to give you anything, that's going to converge. It's just not going to happen. So you know that that series diverges. Now, what if you had this series, sum is 1 to infinity, of negative 1 to the nth power, n over n squared plus 1. That was your series. This makes it alternate, and this is the numerical part of it. So we want to do, first things first, part A. Do the terms decrease? Okay. Well, one way to do that is to start plugging in n is equal to 1, 2, 3, 4, 5, and you can certainly do that. And you will find that the terms do increase. Yes, they do increase. You can sort of see that by plugging in a few n's, but you can also just look. As n increases, the bottom is squared, so the bottom is going to start getting bigger faster, and so this thing is going to be driven down and down. So the terms do decrease, okay? And part B, let's go ahead and officially take the limit as n goes to infinity of this, n over n squared plus 1. And so you're going to have, if you plug in infinity, infinity over infinity, so your L'Hopital's rule territory. So you go ahead and do that. Derivative of the top is 1. Derivative of the bottom is 2n. And as you approach infinity there, put infinity in, you'll have 1 over infinity, which is 0. So the terms do approach 0. The terms do approach 0. So both criteria are met. The terms decrease. They do approach 0, so it converges. Okay? And this only applies for alternating series. This is an alternating series test. Okay, the next problem is the sum from n is equal to 2 up to infinity of negative 1 to the n of n over natural log of n. That's my series, and this part of it makes it alternate, and those are just my terms. The first thing I want to do is find out if these terms decrease or not. Okay? Do the terms decrease? Well, it's hard to tell. You can start plugging in values here, 2, 3, 4, 5, find out if the things decrease, and you could do that. That probably works just fine. But another way to do it is to pretend that this is a function, so I can say f of x is equal to x over natural log of x. The reason I'm going to do this is I can take the derivative of that function, which is the slope or the rate of change. I can find out if that derivative is negative, and if it is, then that tells me these terms are decreasing. And if it's positive, it tells me the terms are increasing. It's taking the derivative there. So it's something analogous to the fact that these points that I'm getting at every value of n, if you were to connect the dots, sort of look like a function, and that's why I'm able to do that. So what is the derivative here? Okay, it's a quotient, so it's going to be the bottom, which is natural log of x, times the derivative of the top, which is 1, minus the top times the derivative of the bottom. 1 over x is the derivative of natural log of x over natural log of x squared. Okay, so what I'm going to have is I'm going to have natural log of x minus 1 over natural log of x squared. And then what you have to do is figure out, okay, for all values of x, is this derivative positive or negative? Well, this is natural log minus 1, but certainly for all values of x, I'm going to find values of x that have a positive numerator and definitely a positive denominator because it's squared. So it looks like f prime of x is greater than 0, which means that this function is increasing, which means that the terms increase. So the series diverges. Okay? because you cannot have that violates one of the two criteria there. So you can't have this thing if you have it increasing, you can't add them up. And if you were to just do the next part just because you just wanted to be thorough anyway, you could still take the limit as n goes to infinity of the terms, which is n over natural log of n. And so you would have infinity over log of infinity, which is infinity over infinity, so your L'Hopital's rule territory. Derivative of the top is 1. Derivative of the bottom is 1 over n, so it's limit as n goes to infinity. You take the bottom and flip it over of n. So you can see right away that this is going to be equal to a big fat infinity. The terms go off to infinity. They go on bigger and bigger and bigger, so that's another way to prove that the series diverges. So the terms must decrease and they must converge to 0 in order for the alternating series to converge. So the alternating series is a series that has elements that are add, subtract, add, subtract, add, subtract. So they're alternating in sign. That's why it's called that. It's a pretty simple test. You have to make sure that the terms decrease, and you can also have to make sure that they converge to 0. So in order to find out that they decrease, you can start plugging in numbers. That works. Or you can take the derivative and see if the derivative is positive or negative to help you out. And then you need to take the limit to see if the terms converge to 0 or not. And if either of those are violated, it does not converge.